Hello, this is Jeanette, and I'm doing the presentation on seamounts. So, what is a seamount? It is an isolated, elevated area that rises above the seafloor. So, as you can see here, it creates this mountain shape in the ocean. It's usually a volcanic origin, and the bottom is usually hard substrata, and the top never reaches the sea surface. It can rise 1 kilometer or more above the seafloor. Seamounts are widespread throughout the world, but most of them are located in the Pacific Ocean. So, seamounts are very diverse hotspots, and some organisms that live within the habitats are sessile invertebrates. This actually dominates the habitat going from top to bottom. So, many sessile invertebrates like corals, sea fans, soft coral, hard coral, sponges, and anemones can be seen throughout the seamount. Plankton and larvae can be found. Fishes like the orange ruffy, hagfishes, moras, and many other type of fish can be found as well. There are many mobile bottom invertebrates like crustaceans, burrowers, fish, sea star, brittle stars that can be seen along the bottom. And manta rays, dolphins, sharks are some marine animals that you can see throughout, and seabirds also can be near the top in some locations. And there can also be animals like turtles and whales. And these seamounts provide lots of nutrients and food for different type of animals. There's actually a controversial topic that is in continued discussion that that seamounts are highly endemic faunas, which just means that there can be some organisms that are only found in seamounts and not in other locations. So, some physical characteristics of seamounts. Their pH tends to be slightly normal to highly basic pHs. And actually, one of the highest pHs in the world was 12.5 in a seamount in Hawaii. The temperature actually gets colder towards the bottom of the seamount, and it can go from 12 degrees Celsius to the top, all the way to 2 degrees Celsius at the bottom. For dissolved oxygen levels at lower water depths, there tends to be more dissolved oxygen, ranging from 4 to 5. And then at higher water depths, there tends to be less dissolved oxygen, average of about 3. Salinity is higher towards the top, and it tends to drop towards 1,000 meters, then rises again towards the bottom, but not as high as it was at towards the top. When it comes to light, there is less light towards the bottom as you move down, which reflects how there's colder temperature towards the bottom. And reactions with the mantle actually creates a lot of material like gases and other alkaline substances. So seamounts actually have really complex current systems. There's high velocity currents that sweep along the seamount summits. Strong bottom currents leave hard bottoms or soft sediment beds that have rippled surfaces. And also the currents can influence the planktonic larvae settlement. So most planktonic larvae prefer hard substrata like the iron manganese nodules that can drop down to the boundary layer with active current environments. And these regional and tidal currents with seamounts can create eddies, which is basically circular currents of the water that can create larvae retention, which just means that there'll be a lot of plankton up on top. And some flat top yachts, which is the top right here, which is the top of the seamount, can have calmer water conditions, which can create more soft sediment. So as we can see in the picture, there's a lot of recirculating flow going around the seamount, coming from the localized upwelling towards the bottom to the top. And when it comes to the larvae growth and dispersion because of the currents. We can see that the spawning happens towards the top, and it can spread across. And this is important because seamounts help create a lot of plankton activity, which can help feed other bigger organisms that eat the plankton. So just to quickly mention, there are a lot of undersea mining and overfishing that's happening in these seamounts, and there are more fish endangerment towards these areas since large fish schools can be easily fished around seamounts. For example, like the orange roughy are becoming extinct because of how much they are fishing them. And many people want to exploit the seamounts because of their volcanic origin and the metal deposits that are created in the bedrock. So it's just important that we start protecting the seamounts before they're completely destroyed by human influence. And that was Seamounts, and thank you very much.